Okay, in this video we want to find and classify the critical values for f parentheses x comma y is equal to y cubed minus 6y squared minus 2x cubed minus 6x squared plus 48x plus 20. In the last video we went over our reference table we use for second derivative test. So let's get started. So the first thing we wanted to do is take the first partial derivative in terms of x and y, and when we take it in terms of x, we would get negative 6x squared minus 12x plus 48. Then we do the partial derivative in terms of y, so we would get 3y squared minus 12y, and the rest would be 0. And now we will take the second partial derivative, so fxx, and when we do that, we would get negative 12x minus 12. Then we do fyy, we would get 6y minus 12, and lastly we do fxy. So we can choose x or y. Let's just do x. We have no y terms, so it would be 0. And now we can get the critical points. So we simply factor out our negative 6x squared minus 12x plus 48. And when we factor it out, we would get negative 6 times x plus 4 times x minus 2. So our critical terms in terms of x would be x is equal to negative 4 and x is equal to 2. We do the same thing for y. We say fy is equal to 0. So we would have 3y squared minus 12y is equal to 0. We would factor, and we would get 3y times y minus 4. And so our critical terms in terms of y would be y is equal to 0 and y is equal to 4. Okay, so now we will use our reference. And so our points will be 2 and 0. 2 and 4, also negative 4 and 0, and negative 4 and 4. These are our 4 critical points. And now we apply our formula. So we say d is equal to f of xx times the second partial derivative in terms of y minus fxy squared. And so what we're going to do is essentially plug in our critical points for like 2 comma 0. We plug it in. So we would get negative 12 times 2 is negative 36. Then we plug in a y. So y is 0 for this, so 0 minus 12, so negative 12. And what we notice here is that we have a value greater than 0. So d is greater than 0. So it's one of these two, local max or local min. So then we use fxx. And when we did it, our fxx was negative 36. Negative 36 is less than 0. So it's a local max. It's going to be this. This is what we have. And now we do the same thing for the other 3 critical points. So when we plug in 2 comma 4, we would get negative 36 times 12. So we would get a negative value of d. A negative value of d is less than 0. So automatically this is a saddle point. Likewise, we do negative 4 comma 0. And when we do that, we get 36 times negative 12. So once again, a negative value, so it will be a saddle point. Lastly, we do negative 4 comma 4, and when we do that, we would get 36 times 12, so d is greater than 0, and our fxx value is 36, so greater than 0, and so what we will have is a local minimum. And that's all we need to do for this type of problem.